Today we'll begin exponential function, but we'll exponents before we proceed into sketching of exponential function. But just for today, we'll state an exponential function can be described by the equation y equals a to the power x, where a is greater than 0. The next lesson will go into details on why an exponential function is y equals a to the power x. But for today, we will review exponents. Exponents of a number, the exponent of a number says how many times to use the number in multiplication. And it's written with a base and an index or a power. So the base tells you then what number I would like to multiply, and the exponent tells me how many times that number should be multiplied by itself. So a to the power 2 says that you use 8 twice in a multiplication, so 8 times 8. Exponents are also called powers or indices, just to note. Example, 5 to the power 3 is 5 times 5 times 5 equals 125. Sometimes called 5 to the third power or 5 cubed, means 5 to, either way is also correct. 2 to the power 4, sometimes people say 2 to the fourth power. 9 to the power 6. So in general, a to the n tells you to multiply a by itself. So there are n of those a's. Sometimes because of the keyboard, you'll see the symbol for exponent. So when we have negative exponents, it means dividing. 8 to the negative 1 means 1 to the power 8. 1 over 8. 5 to the negative 3 means 1 over 5 to the power 3. So in general, a to the negative n is equal to 1 over a to the power n. So calculate a positive exponent and then takes its reciprocal. Just to review the law of exponents before we go into some examples. X to the power 1 is x. For example, 6 to the power 1 is 6. X to the power 0 is 1. 7 to the power 0 or 6 to the power 0, except for 0, it's 1. X to the negative 1 means 1 over x. It's the reciprocal. X to the n times x to the m gives me x to the m plus n. For example, we have x to the power 2, x to the power 3 means x2 plus 3 gives me x to the power 5. We add the exponents. Notice the bases have to be the same. And we go through these similarly. We'll do a few examples that will show you how to apply these laws. And the law about fractional exponents, x to the power m over n, the denominator becomes your roots. So x to the power 2/3 becomes the cube root of x to the power 2. So let's take a few examples. In this example here, we asked to identify the coefficient, the base exponents, and power of each expression. Notice this in the bracket will refer to my base. So you see my base is -3x. The coefficient, there's a 1 front here. It's unwritten because it's 1. So the coefficient is equal to 1. The exponent is 4. This example here, now this could be written as -1 x to the power 5. So this becomes your base, and this is your coefficient. And this will be your exponent. Similarly here, you have 1 x -3. This is your coefficient. Which is 1. Your base is equal to x, and the exponent equals -3. Evaluate this expression means 2 times 2 times 2, which works out to be 8. It's 2 to the power 4, 3 to the power 4, which works out to be 16, 81. Now this becomes 3 to the power 36, which is 112. Evaluate each expression. We substitute x3 for x into each, 2 for y. So it's roughly 3 times 2 to the power 3 minus 3 to the power 2. 3 times 8 minus 9, 24 minus 9 gives me 15. We have -3 times 1 to the power 2 plus 1 times -2 to the power 5. So -3 plus -32, which is -35. We have a few more, though. Because it's in brackets, you multiply each exponent by 2 inside of the bracket. So this becomes 3 times 2 is 6, x to -10, or y. This can be written as y to the power 10. Y -4 can have the reciprocal as y to the power 2. Because we're multiplying, we add the exponents. What multiply by itself 3 times gives me 125. 5. And how many times do I need to multiply 2 by itself to give me 64? Be 6. We multiply the exponents, so 0.5 becomes negative 6, which is the same as, and if you simplify this, it becomes 64. 2 to the power of 3, 3 to the power of 3, we have negative 3, which results in 2 to the negative 9, 3 times 3 to the negative 9. If you simplify that using our calculator, it works out to be 38.44 approximately. And the final, because multiplying, basically the same, we add the exponent. X to the power of 3 plus. So you have 9 over 3 plus 7 over 3 gives me x to the power of 16.